Well, like Matt said, we are AIAA. We are a competitive team that runs to a competition annually. I'm Jake Mallums. I'm the team lead for the team. Here are the other members of the team. And this year, the competition will be held in Tucson, Arizona. So,
as Jake talked about, we're an annual team. So with our designing, we take a look at last year's competition, both our own progress and performance in designing our airplane through those constraints, and also the other team's reports, because the top 5 teams from the competition get their reports published online on the website. So we took that into our decision making and design our new aircraft.
And more onto the report, we did analysis of the scoring system and determined that the report was going to be crucial in our team's success. We realized all of the teams who scored in the top 10, even top 20, received 80% or above or so on the reports, because everything is multiplied by your report score. So we determined to study all of the published reports online and determine how we could improve our last year's report in order to meet criteria necessary to score well in the competition.
All right, so last year we had a larger group, so the group situation was a little bit different than what it is this year. Last year we had a real static kind of groups setup, and so this year we're going to change from that and go more dynamic by having small groups of 3 or 4 people kind of take on an individual task or group task, however they set it up each week. And so instead of everyone just doing structures in that group, we're going to try to branch out and have everyone do multiple parts of the airplane. So this week I might have done structures, and next week I might be working on aerodynamics too.
all right.
And here is our Gantt chart, which kind of gives right now our estimated plan for different milestones that we completed. There's 3 main chunks. There's up top the aircraft design, and then there's aircraft construction, and then aircraft testing. And some major points, one would be the design freeze. We hope to have everything finalized and all the major design points finalized by the end of February, and make no more changes to the design by then, and just be creating the final model.
And we've been working on the concept model, just going through the different design aspects and trying to get a nice SolidWorks model set up so that we can go into starting our prototype model, which we will hopefully start at the beginning of December and work up until winter break. And then hopefully we'll continue working on that right after that and start working on our final competition model by the start of February, maybe more like middle of February. We're not quite sure yet, because that's more when we started last year. And then we'll start our most of our testing will go out through the whole year, depending on whether we're testing a propulsion system or battery, any of that kind of stuff. Or then we plan to start flying right after winter break, hopefully with our prototype plane, and then start flying with the competition plane as soon as we get done with that around beginning of March.
All right, and so now hear a little bit more about the tasks that we've been working on this year.
So this year we were doing a little bit more of score analysis. So big part of our score this year is the number of servos we use or motors. So, and also our weight. So our entire flight score is divided by what they call the rated aircraft cost, which is number of servos times the weight of the plane. And so we assumed we were going to have 5 servos, and we had some scoring aspects that we assumed we were going to do top 75% scores across the board. And then so we were trying to determine which motor we were going to go with. A bigger motor that has more thrust, or a smaller motor that weighs less, so we need less thrust. And we've been starting to do more of these analysis, and we came up with we're going to try to go with a smaller motor because it'll give us a lighter plane, which will give us a smaller rated aircraft cost.
Right now, we've been working on quite a few just design and conceptual traits, trading aspect ratio to wing area, trading thrust against weight, really just looking at how the different performance parameters all tie together. And like Ryan said, we're really trying to toned down our weight from years past. In the years past, we built big planes that need a lot of thrust and a lot of lift. We've found out that the competition really is won with smaller planes with high thrust and quick speed. So we're just working on a lot of the sizing trades right now.
So back to the pro and con table on both motors there. Unlike last year where we chose a motor and then tried to build a plane around it, we decided to choose a thrust to weight parameter and then find a motor system that would work with that. So we aimed for a 1-to-1 thrust to weight ratio. And the two motors that we tested have different kilovolt ratings. And what those kilovolt ratings mean are for each kilovolt, you need that many voltage, that many volts on your battery for one rotation of the motor. So the higher the kilovolt rating, we would need a larger battery, higher voltage to power that. So with the smaller motor, it has a lower kilovolt rating. So we don't need as large of a battery to get our 1-to-1 thrust ratio.
With our batteries, we started off, we're trying to create our own battery pack like we did last year, and that has many different aspects in it because we have to decide how many milliamps we want, what kind of voltage we want out of it, and we have to vary how many cells and how big the battery's going to be because of the weight limit. And so we've been testing those with the different motor combinations to figure out what kind of flight times we can expect, and then vary the voltage as well because that affects the amperes that we're pulling, because with this type of battery that we're restricted to, we can only pull so much power from the battery per like unit time. So we have to have higher voltage ratings so that we're not pulling too much out at one time. And I think we ended up, we're thinking about a 1500 milliamp hour battery pack with around 27 volts, which will hopefully get us around at 9.
All right. So now a little bit more about how we're going to try to reach these goals and where we're going to end up.
Okay, so right now, as it was on the schedule, we're trying to design the plane, and by November, we would like to start building actual plane. And by the end of the year, we'll want to actually try to fly the plane. And this year, the groups is hoping to place in top 25% in competition. And in the spring review, prototype is going to be built and have to be flown by then.
All right. So here's a look at our budget.
And based on last year's budget, we took a look at it and looked at this year's competition and requirements and showed materials, the materials that we might need for this year and how we might go about doing it. So.
Okay. And now for closing.
So we wrote up a proposal to Boeing to get more funding. Boeing gives a lot of money to amateur trainers. They like little projects like this for so we're asking for money to possibly be able to build like an extra plane or buy spare parts, things like that, and in return we're going to put their name on it.
Right.
And hopefully we'll be able to show off that name with good.
And so overall, we're looking towards a really successful year. I think we've got a lot of things in line, and we've learned a lot over the past 3 years of this group going through. And I think we've made significant strides as to our success over the past 2 years. I'm really excited to see where that next step is going to land come competition in the spring. So with that is the end of our presentation. Are there any questions?